In this unit, we are going to see what the matrix equations are. We are going to define what a matrix equation is and how we can solve them. For this, we have to know what a matrix is and what operations we can do between them. So we will start by saying that a matrix equation are equations in which matrices intervene. For example, this one you have on the screen, I have a matrix 2 times 2 plus x times another matrix 2 times 2 equal to a matrix 2 times 2. Obviously, x has to be a matrix of an adequate size so that all these operations can be carried out. For example, x could not be a matrix 3 times 3, since 3 times 3 times 2 times 2 cannot be multiplied if we remember the matrix product. Then, the equation itself marks the size of the matrix x. In this case, objectively, we could say that x can have a size of 2 times 2 so that all this can be carried out, or 1 times 1 could be a number. Another example would be a times x plus b equal to c, where A is a matrix 2 times 2, B is matrix 2 times 3, and C is matrix 2 times 3. As I said, the sizes must be squared to do the corresponding operations. Then, this is already marking us that X has to be a matrix 2 by 3, necessarily so that we can carry out all the operations. These are matrix equations, and to solve them, they are used in the properties that meet the operations with matrices. We have to remember them all so as not to make mistakes in the calculations. Let's see how, for example, we could solve these two equations. If we start with the first one, we are going to solve this matrix equation. As I said, x, the size of the matrix x, will be marked by the equation itself. In fact, the first thing that happens to us is that we do operations between matrices. I can subtract all this expression, this matrix, so that it disappears. Because adding a matrix, the matrix 0, is like doing nothing. And of course, if the rest of this side is equal, I have to subtract it. Also to this other side. It is like isolating. Well, if we isolate the x in the measure as possible, then x times the matrix 3, 1 minus 4, 2, will be equal to this matrix. 3, 6, 5, 0, minus this other matrix. We subtract it. We carry out that operation, and the result is a matrix 2 times 2, which, in the end, what we have left is this other simpler equation. X times a matrix is equal to another matrix 2 times 2. What can we do next? Well, the way to eliminate this part of here, this matrix here, is not to be divided. You know that division is not a valid operation between matrices, but we can use the concept of inverse matrix. If matrix 3, 1, 4 minus 4, 2 was invertible, then what could we do? Well, multiply by the right. Remember that the product of matrices is not commutative. Then if I want it to disappear, I cannot multiply by this side and here on the left. I have to multiply by the right, so that they are in contact with those two matrices, and I can reduce it to the unity or identity matrix, and so it disappears. So if I multiply by the right, I also have to multiply by the right on this other side, by the inverse matrix of that matrix, if it exists, obviously. So, what is the first thing we have to make sure? Let's see if that exists, because if that exists, what happens? Well, once I multiply this product of these two matrices, that gives me the matrix unity, and we know that the matrix x times the unity matrix is the matrix x itself. Then, if this inverse matrix exists, we have solved the problem. The matrix x is this matrix product. Well, let's make sure first that this inverse matrix exists. How? Well, by calculating it using the Gauss method. Remember, to use the Gauss method, we put the matrix, and the matrix identity or the matrix unity on the side, and we have to change these two matrices by doing valid operations. Well, let's start. If we do all those operations, first we get a 1 here, a 0 here, then a 1 here, and 0 here, another 0 here, and a 0 here. And we get that we have been able to interchange this matrix. With this one, that means that this matrix is invertible. And that, in addition, this inverse is exactly this matrix that appears to us here, on this other side. Well, we have seen that. Well, we have seen that the matrix is invertible, and that the inverse is this one here. Then, we can replace it and find the value of the x. That is, if I substitute in this expression that we had for the x, the inverse matrix, by its expression, well, this product of two matrices gives us exactly that. The x is 5, 1, 0, minus 1. It is a matrix 2 by 2 that has precisely those elements. Then we have solved the matrix equation. As you can see, the equation itself has given us that the matrix x is a matrix 2 times 2. It gives us exactly the size of the matrix and also its elements. Let's look at the other example. If now I want to solve the matrix equation by x plus b equals c, being A, B, C, these matrices that we see here on the screen, well, the same as before. First, we try to clear the x as much as possible. As I said at the beginning, the matrix equation itself will determine the size of the matrix X, which in this case necessarily has to be 2 times 3, although it will come out directly with the calculations. But we can already think about it, so that this product can be done, and that in the end, it is a matrix 2 times 3, to which it can be added another matrix 2 by 3. So, taking into account this, we isolate it. If I isolate it, the first thing we would do is take the b and subtract it to the other side, in x equal to c minus b, the same as before. To isolate the x, this a should go to the other side. How? Since the division does not exist, then we have to use the concept of an inverse matrix of a matrix again. So, if the a is invertible, that is, if it has an inverse, I can multiply, in this case, by the left. On this side of here, I can multiply with the matrix, so that the a and the minus 1 are in contact. And of course, if I multiply this side of the equality, I necessarily have to multiply. Also on the other side, then I would have a inverse times a times x equal to a inverse times c minus b. A inverse times a, as you know, is the identity. And the identity for any matrix is the matrix itself. Then it remains that the x is necessarily a inverse times c minus b, as long as this inverse matrix exists. Then, as before, we have to see if there is an inverse matrix or not, or does not exist. And if it exists, we substitute it there, we do the corresponding operations, and we have the result. Well, let's see. If A inverse exists, then we use the Gauss method. We put the matrix A, we put the identity matrix, and we perform operations to see if we can exchange these two matrices. Performing valid operations, we arrive at that. We have been able to exchange these two matrices, with which the inverse of A is minus 1, 1, 2, minus 1. That inverse matrix exists. Then, only we have to substitute that inverse matrix, which is the inverse of A in the expression of the x to obtain the solution of the matrix equation. Therefore, x is minus 1, 1, 2, minus 1. That is A. Inverse times c minus b. We perform the subtraction between c and b. We get this matrix. The product of these two matrices is 1, minus 1, 1, minus 2, 1, 0, which is the value of the x. As we see, x is a 2 times 3 matrix necessarily, which its elements are the ones that you have here. The matrix equation determined the size of the matrix and the value of its elements. We have seen what are the matrix equations and how to solve them. Thank you very much for your attention.